Okay, so for part 2 I have a force of 3.2 Newton acting on a mass of 600 grams decreases uniformly over a period of 8 seconds until it becomes 0. Sketch a graph of the force acting on the 600 grams mass. Here the keyword is uniformly. Here what uniformly is telling me is that it will have a constant gradient. So it will be a line. I can tell by this word that it will be a straight line. Okay? So first I have to sketch a graph of the force acting on the 600 grams mass. And I know the force on the y-axis, and on the x-axis I have time. So the highest value here is 3.2 newtons, and it will get to 0 after 8 seconds. So the graph looks something like this. It's a triangle. Okay. Now letter B. Use your graph to determine the impulse felt by the mass. Remember that impulse is the area under the curve in a force against time graph. So this problem reduces to finding the area of that triangle, which is 1/2 of the base times the height. So that would be 1/2 of the base in this case delta t is 8, and the height is 3.2. Okay, like this. When you take that number, that is 12.8 newtons times seconds. Alright? All I did here was find the area under the curve, which is also the impulse. For letter C, hence, calculate the final speed of the mass. For this you need to remember the impulse momentum theorem, which relates momentum with impulse. So impulse, we just found it in the previous exercise. And momentum, we know that is delta p in this formula. That is, by definition, the mass multiplied by the change in velocity. So if I know the mass and I know the impulse, I know that delta v can be found by taking this division, 12.8 over 0.6. So the variation in velocity is 21.333 periodic. But now I also know that delta v is final velocity minus initial velocity. Solving for Bf, that gives this formula here, telling me that final velocity will be initial velocity plus 21.3. Okay, this problem doesn't state that, so like this is the right answer. Some of you took the assumption that V0 was 0, that this object was at rest. However, none of that is specified here, but for this problem, I also consider if you wrote this as this is also an accepted answer. However, the most correct answer is this one. But since most of you took that for granted, took the assumption that is also accepted for this particular problem, since the problem is a little bit ambiguous and doesn't provide more context on knowing if this is zero or not. Okay.